Okay, shh. Thank you. All right, rational exponents, or in other words, fractions. Fractional exponents, right? That's all about. What would a of 1 over b look like? Well, just so you know, a to the 1/2 you've actually seen before. That's just the square root of a. Right? That's all that is. And a to the 1/3 is simply the cubed root of a. Right? So no matter what you have, if it's a to the 1 over 25 would be the 25th root of a. Just so you know, okay? Consider 25 to the half. Do you agree that 25 is just 5 squared? And notice that when it's a power to a power, you multiply the exponents. So 2 times a half is 1, and that equals 5. So 25 to the exponent 1/2 is just 5. However, notice the square root of 25 is 5. Okay, fine. So we're just saying that 25 to the half equals root 25. That's all we're saying, okay? Consider 8 to the 3rd. Do you agree that 8 is the same as 2 to the 3? So 2 to the 3, a power to a power, we multiply exponents. 3 times the 3rd is 1. 2 to the 1 is 2. However, the 3rd root of 8 is the 3rd root of 2 times 2 times 2. This is asking what multiplied by itself 3 times gives us a 2. What multiplied by itself 3 times gives us an 8. So the cubed root of 8 is 2. So 8 to the 3rd is the 3rd root of 8. Here in general, this is the formula. Okay. A to the 1 over n is asking for a number which when multiplied by itself n times results in the number a. Okay, how would we write x to the 1/2 in radical notation? Does that seem blurry to you? I don't know if it's my cruddy glasses or my there, I think that's better, right? Okay, could someone write this in radical notation? How would you write that using a square root sign? Root of x, right? And this would be -8. Can we take the 3rd root of a negative number? Huh? Yeah, you can, right? We can't take the square root of a negative because this is -2, -2, -2, right? The question just asks us to go to there, but I'm just kind of trying to speed up the process, and that just equals -2. So when it's odd, you can have a positive or negative value under the radical sign. This, I think, you know, is just the 5th root of ABC. And this is just the square root of 25x to the 16. What's the square root of 25? 5. And the square root of x to the 16? 16 times a half? 8. You took the square root of 16, but that's not what, it's the square root of x to the 16 is 16 times a half is x to the 8. Do you see the difference? That's important. Write an equivalent expression using exponential notation. Okay, we're going to go the other way now. So this is going to be 9xy to what exponent? Perfect. And this is going to be x cubed y over 4 all to the exponent 1 over 7, right? And be careful, it looks like x is included in the square root sign, so this is 5x to the 1/2. Right? When it's a half, the 2 there is understood. We don't write it in because that's a bit redundant. Okay. What happens when we have x to the 2 over 3? My goodness. This is the same as 2 to the 3 to the third. Well, that's 2 to the 1 times 2 to the 3 to the third, right? This is what it's equivalent to. Do you see? When you add exponents, you get 2/3. And 2 to the 3 times the third is 1. 3 times the third is 1, so that's equivalent to 4. So if we look at the third root of square root of 8, the third root of 2 times 2 times 2 is 8 all squared. So the third root of 8 is 2, but we still have the squared, and that is 4. So what we're saying now is this equals this, right? The denominator of the fraction goes within this root sign in there, and the numerator of the fraction goes outside, or it can go like this. These two are equivalent to each other. So if you just learn the pattern, the denominator of the exponent goes here, the numerator goes on top of the a or on top of the whole thing. This is both the same thing. If it's a negative exponent, we just reciprocate it. So let's take a look. This you can write in two ways. It's the third root of 27 squared, or it's the third root of 27 all squared. These two things are the same thing. It's whatever you want to work with. So I like this one better. What's the third root of 27? What multiplied by itself 3 times gives us 27? 3, right? So that's 3 squared, right? Don't forget the 2, and that equals 9. So this, again, we take this 2 as the square root of 25. We can either write the 3 here, or we can write it here. To me, this one looks easier in this case. So we can write 5 cubed equals 125. Can I explain anything better? Just remember, the numerator of the fractional exponent goes on the outside. The numerator here is 3, that goes on the outside. The denominator goes right in there, and since it's 2, we don't write it because it's a redundant thing to write. It's understood. Let's do some examples. Oh, we can handle this. How would you write this using exponents? Nine to the power what? 4 over 3, right? This goes in the denominator, right? That thing inside that little v there, and that goes in the numerator. What about this guy? Be 7xy to the what? 5. Perfect. Write an expression with positive exponents, and if possible, simplify. So it's 1 over 9 to the half. Do you know that that's the square root of 9, so that equals 1 over 3. What about this guy? What do you think? Do you guys not have example 6? I guess not, eh? We'll do a few more examples after this. What do you think? What's this guy equivalent to? Write it with positive exponents. You know, when it crosses the division line, the negative exponent becomes positive. But we cannot evaluate that, can we? This one? A really big number divided by? Yeah. Can we do anything with this? Yeah, no, you can't do anything. Not if it says express with positive exponents and see what you can do. Okay, you tell me what I do with this guy. Anyone want to volunteer? This is what? Write it as a positive exponent. Remember when it crosses the division line, the sign of the exponent changes, right? 1 over 64 to the 2/3. So that's the same as the third root of 64 all squared. What's the third root of 64? Yeah, perfect. Okay, anyone want to try this one? Write it with where does the 4 go? Does the 4 go in the numerator or the denominator? It goes, the 4 goes down? But does this exponent apply to the 4? No, so it's x goes down. Perfect. What about this guy? What do you think? What would you like to do with this guy? The easiest way, if this is a negative sign, let's just put, and it applies to both the numerator and the denominator, we'll just swap, right? So this will be 7s over 3r to the 5 over 2. That's all we can do there. I want to do a few more examples with you. Let's try this guy. Sorry? You have example 6? Does everybody have example 6 on their package? How come I don't have it? Oh, for heaven's sakes. The pages were stuck together. I was worried. Okay, tell me, what do you get? Use the law of exponents to simplify and or evaluate. What did we get? 4 over 5. Add the when you multiply something with the same base, add the exponents. What do you get on this one? This is a division line. Wouldn't this be a to the 1/4 minus 1/2? A to the negative quarter, right? Because 1/4 minus 2/4 is that, and that is perfect. And this is, oh my, 7 point, right, a power to a power, multiply exponents. The, when you these divide out, 3 goes into 3 once. And this is going to be 7.2 to the 2/4. And remember to always simplify. Remember when we have power of a product rule, the half applies to this one and to this one. So we have a to the negative 1/2 times 1/2 and b to the 2/5 times 1/2, right? This, because of the brackets, this applies to both exponents. So that leaves us with a to the minus quarter times b to the 1/5, right? 2 divides out, we're left with 1/5. And if we express with positive exponents, we have b to the 1/5 over a to the 1/4. Again, power to a power, we're multiplying the exponents. 6 goes into 3 once, 3 goes into 3 once, 3 goes into 6 twice, so it's x to the 4. Again, multiplying with the same base, we add exponents. So this is going to be x to the 1/2 plus 2/3. To add them, we need a common denominator, right? Our common denominator is 6, right? 3/6 plus 4/6, and that is x 7/6. Just don't forget your BEDMAS rules. When you're dividing, you subtract exponents. Common denominator is 6. And that equals x to the 5/. Am I going too quickly? It's okay? So because of these brackets, the exponent applies to the 8 and to the x to the 6. So that equals 8 to the 2/3 times x to the 6 to the 2/3. So this is the same as the 3rd root of 8 all squared. And this is just, well, 12, that's just x to the 4, right? 6 times 2 is 12. 12 divided by 3 is 4. What's the 3rd root of 8? Yeah, so 4x to the 4. Ooh, the 3rd root of the square root of x to 10. So this is x to the 10. The square root is to the half, and the 3rd root is to the 3rd. Does everybody see that? The square root is to the half, and the 3rd root is to the 3rd. So 10 times a half is 5. 5 times, so it's just x to the 10 times a half times a 3rd. And that's x to the 10 over 6. Reduced to lowest terms always. That's 5/3. Did you want to see your marks on your test?